though, is the slight problem.
Right now it's not wet.
Okay. So part of this, I think, is confusing because you're not doing a problem. Like, if you had numbers, I feel like this would be a little easier to understand. We'll find out. The way he said you just set it up, I think even if you get it right, you're kind of like, what do I do? What does that mean? So let's just start going, and you can let me know where there's issues and whatever. So, an ice cube is melting. Part of this is you guys, well, you guys specifically, but typically, calc classes, or most students, suck at remembering like general formulas for area and volume of things. So, like, what's the area of a circle? Pi r squared. But you like weren't sure, right?
No.
What's the circumference of a circle? Pi r. Should I like write some of these down? Are you like a little embarrassed that I have to write down the circumference of a formula circle?
No.
I kind of want you to. Don't. This is not like number one. I'm just using this as like.
It was in 8th grade. Yeah. The last time we learned this was 5 years ago.
And we never had to know.
Okay.
It was just
Okay. So this is for circles. What about a sphere? Everybody know the volume of a sphere?
Wait, what part is something?
4/3 pi r cubed. Sorry. 4/3 pi r cubed. Rectangle. How bad are we here? Length times width. Perimeters 2L plus 2W. Did you say what's L and W? This is loser and winner. Guess which one you are. Cube. What's the volume of a cube? So I give you an edge. What's the volume of that? Right, that's fine. That works. But if they're all the same, couldn't I say like edge cubed or L cubed or side length cubed or something? What about the surface area of a cube? Length times width, they're the same, so that's one of your faces. You have E squared. Times how many faces are there in a cube? So it'd be 6L squared or 6E. Some people do E for edge. You've never learned that?
No. Kind of sounded like no.
Does it make sense?
yes.
That's okay. Just like I've like actually done it. Yeah. What if I have a box that's not a cube? So the volume of a box is length times width times height. What about the surface area? Well, I shouldn't have erased those. I'm sorry. Just write down some of the formulas. Yeah, great math probably actually really help with that. Just general like area. Yeah. Close. They're all different. You're assuming that like 4 of those sides are the same, but we don't know that. So it's 2LW plus. It's 2LW plus 2LH plus 2HW. Because you'll have like, like this side and there's 2 of them. This side and there's 2 of them. This side and there's 2 of them. So if you say like 4LW, I think you're thinking 2 of these are the same, maybe. God. No. Damn. What's that? Sorry, what? Alright, I'll calm down. You figure out your question. Should we draw it again and explain it like more? Because that was pretty like.
No, I got enough.
You're right. Other questions on those? Here's more that people suck at. Maybe not you guys. I don't know. What's tan? for Jason.
Okay. Yeah. We're going way back. We're going to.
What sign?
Why are you speaking in gibberish? Sound like John Cena.
Should be putting theta here. Cosine? Jason over hypotenuse. Did you guys learn this like SOHCAHTOA?
Yeah. This is what got me through. Oh my god.
Okay. Area of a triangle?
Something half.
So just put a half there and we'll call it good.
Yeah. Base.
Do we know the Pythagorean theorem?
Yes.
Yeah. Can you use Pythagorean theorem on every single triangle there is? No, it has to be right triangle, right? No, just right.
That's a thing, but
There are special right
it
triangles,
doesn't
yeah.
have to do with Pythagorean theorem.
But you can use Pythagorean theorem on any right triangle. You're thinking of like 45, 45, 90, and like 30, 60, 90. I'm terrified to put that on the board, so we're not going to. So I think that might be, I mean, we might come across more. But I think that'll get us going at least. So the general idea is find an equation that relates the things they gave you in the problem. So what I see here, I see cube, I see volume, and I see edge. So can you write an equation that relates the volume of a cube and its edges? So what is the volume of a cube? And then if you think about the variable has to be like an edge. You can call it whatever you want. So the volume of a cube is length times width times height, right? Or of a box, of any rectangular. Is it a prism? It's not a prism.
Oh my gosh.
You know how you told me I can't use straight line?
Yes.
In the video, he said it about 8 times.
Did you really?
And I was like, ha, ha. He said it again, ha.
I mean, it's not wrong, but it's just like, there's no point for it. They must have So, if length, width, and height are all the same because it's a cube, couldn't I just say this is volume equals length cubed? Like for a lot of people, that's the hard part of these problems, is just getting started, which is not calculus. It's like, kind of your geometry formulas and can you relate them with the problem that's going on. And then the idea is every variable that you have, in this case there's only two, is going to be changing as time passes. So it's really implicit differentiation. Do you remember when we multiplied? You took the derivative of a y, you multiplied by dy over dx. Well, everything in here is implicitly tied to time. So every variable you take the derivative of, you multiply by d whatever over dt. Because they're all tied to time. So as time changes, so the idea is we've got a cube here. But the length is going to be expanding or contracting or something. But if the length contracts, let's say, of every side, doesn't the volume also change as that happens? So when one thing changes, everything else changes as time goes by. So the overall variable is time. We're expressing these two things as a function of time. So the idea is, what's the derivative of v? It's 1. And I took the derivative of a v, so I multiplied by dv over dt. What's the derivative of L cubed? That would be 3L squared. But I took the derivative of an L, so I multiplied by dL dt. And then what do those mean? The V over T stuff, or the whatever over dt, this is the rate of change. Because you're at the derivative level now. You took a derivative. So that's the rate of change of volume. That is the rate of change of length. And that is just straight up length. But like that just looks just abstract right now. So I wonder if that's why it was harder for you guys. So let me give you a second to write it, and then I'll tell you like what the problems would look like. they'll give you like the length, the edges of a side are decreasing at like 2 centimeters per second. So then you would put in a negative 2 here because it'd be decreasing at negative 2. So that the sides are decreasing at negative 2 centimeters per second. At the instant the length of the side is 4, so like you freeze that snapshot in time, how fast is the volume change? That's the kind of question. But then you have numbers to plug in. I just think it's a lot easier in that scenario. But let's keep rolling with this. We'll set them up and then we'll move on from there. The questions on one. I talked about a lot of crap there. So if I look at 2, I see a rectangle, I see width, I see length, and I see area. So right there is my key, area of the rectangle. So what is the equation of the area of a rectangle? So you want to use what they used. So what's the area of a rectangle? We have to review this one too. Loser times winner. Now be careful when you take the derivative. So what's the derivative of A? It's 1. Then I multiply by dA dt. And what does that dA dt represent? The change in the area. How quickly the area is changing. So area and change in area are 2 different things, right? Area is a snapshot in time. What is it right now? dA dt, or the change in the area, is it getting bigger or smaller, and by how much? Now what do I need to use here? You're good that it's a rule, but it's a product. So you guys learned fig, right? So this would be L prime times G. So what's the derivative of L? dL dt times the second thing, so just W, plus GIF, so what's G prime? dW dt, and that's L. And then they'll give you certain parts of this and ask you to find the rest. So let's just go through and make sure we know what they all mean. So we did this one. What's the dL dt telling you? Change of the length. This is the actual width. This is change of the width. And this is the actual length. Does that help? Like 3 people this morning were like, you're going to need to explain that. That's totally fine. But does that help? Should I keep going? Do you want to try them? Let's have you try like the rest of them. On there if you haven't already. And then let me know when you get stuck and I can figure out like what I can do to help. You might have to Google. Oh, cylinders. Yep, they do cylinders a lot. They gave you the volume. Yeah, try it. These are good. They're really good problems. I wish they had given you the math so we could actually do the problems.
Wait, why does it say that?
That's the surface area.
Yeah.
So it's like SA.
The only variable is like the R, right?
Yeah. You guys want to see some wild? That's the volume of a cube, right? Or a sphere. That's the volume of a sphere. I say right like you guys know. That is the volume of a sphere. Does anybody want to argue? Does anybody want to fight about it? Right. Check the derivative of it. What do you get? Isn't that cool? Take the derivative of that. What do you get? Isn't that cool? That's all I got.
One more time. Wait, I have a question on number 4.
No, it works with cubes too. What's the volume of a cube? No, it doesn't work. Never mind. Sometimes I feel like I It's because you got a cylindrical tank, and as the water pours out, the radius of that circle doesn't melt in. Please let me know. Like I'm expecting there to be a lot of questions. I want to go through them. This is a something is not changing, like let's say I have a ladder that's sliding down the wall. What's the rate of change of the length of the ladder? So there's sometimes that you'll set something up, but there's a certain variable that doesn't change. Or like I'm standing here and someone's running across that way. Like the vertical distance from me.
They're running in a circle.
No, the vertical component wouldn't change. Yeah. The distance would change, but the vertical component. I started to say vertical component. I didn't know if people knew what that meant, but I got scared and stopped talking. Then I'd like to start 4.5 today. Hopefully we'll have time to like check this and do a couple in 4.5. Little, yeah. Yeah. Well, they're like in the middle of a couple of problems. I mean, I got a couple of minutes. Should be walking around helping people actually in my class.
Hey, is 3 change or I think it is change. Change? 4 is a number.
Yeah.
It's just. So you can just make, you don't gotta do it.
Why is that? Why are you saying? Oh, you said that the radius of the metal tank stays the same. Even if the water's draining, it doesn't like move shapes. Yes. Take a little wind there. Look at the rate of change in the wind. I tried to probably this. I know.
You should bring sidewalk shop.
That's some sloppy handwriting here, but this is what I got for what I get for 3 and 4. And then they're trying to tell. I think in the answer key they made this 0. So if you have a cylindrical tank, you got some water in there. As the water pours out of this leak down here, whatever, is the radius of that water changing? No. So that's why this would be 0, which actually knocks that entire thing out. Right? So you can really just say it's pi r squared times dHdt. Like this isn't wrong, because if you went to plug numbers in, you'd plug in 0 and you'd figure it out anyways. But if I wanted to like totally simplify that answer. Is that okay for 3 and 4?
Wait, why do you use X, Y, and Z? Just a quick question.
You can use whatever you want, but I look at it like that's an axis.
Okay.
And then like X is horizontal, Y is vertical. But you can use A, B, and C. It doesn't matter.
So it's just
I just think it's easier to keep track of that.
Do you have to make sure that the constants on the outside? Because like for 6,
Hold on. Let me. I think I know where you're headed. But
okay.
give me a second. If that's okay. So I took the derivative here out of this. And then like this is the example I was talking about. The ladder is going to start sliding, so it goes down the wall and then side of the wall. So if if I called the ladder Z, what is my dz dt?
It's 0 because the ladder length doesn't change.
Because the ladder doesn't change, right? The length of it. So that would make this 0 in this situation. But you were asking about 6, weren't you?
Yeah.
Sorry, I thought you were at 5.
No, they used oh my god, the triangle stuff.
Trig?
Yes. Okay. Today's episode of Decipher What.
It's like today's episode of trying to have AP Calculus students do basic geometry.
I did it. I blinked on the thing.
Um,
All of
It
them.
was freshman. I don't think we got to that.
so we got a rocket over here. That's my rocket.
Because to be fair, the end of our geometry.
That is my favorite like card to pull when I don't know something. I just say it over here.
Well, it's like real though, because I think once we got.
Yeah, it's true
circles,
enough
it's
that
when we
you're-
cut off.
My dad asked biology questions all the time. My sister's in the
We never did
go here.
circles.
And I
She
said,
said that's
I don't
work.
go here.
That's all I can find out. I think
Yes.
So for 6, I got a rocket shooting up in the air. And I want to know, so the angle is increasing as the rocket's height increases. So y is getting bigger and bigger. This angle is getting bigger and bigger as the rocket goes up. X actually won't change, right? Like the horizontal distance from you to the rocket will stay the same. So you could use quotient rule to take the derivative of this. Or, if you realize that x is a constant, you can write it like that. So then it's just like 3y, because this is really just a constant. And it might be easier to just use product rule at this point. I don't know if this constant thing is making things easier or worse. But then I would take the derivative here, and what's the derivative of tan? Secant squared of theta times d theta over dt, because I took the derivative of a theta, in this case theta is my variable, because that angle is changing. And then, like, what's the derivative of 3y? Bear with me. What's the derivative of 3y? 3. What's the derivative of, okay, yeah. What's the derivative of 12y? 12. What's the derivative of 200y? 200. Well, 1 over x is just a constant. So what's the derivative of 1 over x? Y. 1 over x, but then I did take the derivative of a y, so I multiply it by dy dt. See, I was heading there, right?
Yeah. You just said 3. I said, am I missing something?
You're just missing what's a membrane.
Yeah.
That's probably good.
Maybe I should read your mind.
So, is that okay for 6?
Yes.
Micah, you good on 6?
Yes, sir.
The people that you are assaulting with your words good on 6? Connor and Will, you okay? Is he bullying you? 7 yet or no? I was just trying to draw. Like, what is it attached to?
Is it higher on
Like that?
Yes. It
So
says
I
that
think
in
problem.
Yeah, but what? So you're telling me it's pulling in by like the top of the flag?
Yeah.
No, like on the dock, there's like a big hole that sticks up and it goes down. So
So it's the opposite. Flip your triangle.
I have a triangle row.
Yeah.
Yeah.
So there's a pole here, angles here, so this is just x, y, z. And then like your x is going to change, your z will change to get closer, but your y won't. Sorry, I didn't give you a chance to do it because I made you all funny. Thank you. So this would be your Pythagorean theorem, x squared plus y squared is z squared. And then if you take off the derivatives, this is a really common one, so you'll get used to the triangle one. Which variable in this scenario is 0? Not y. Are you arguing with me, or are you asking the question why?
Why?
Which variable is 0? It's not the variable y. dy dt is 0. So this is a distance. But how much is this distance changing? It's not. So this part would be 0, which would actually make that whole piece 0. So
Yeah.
you're not wrong. Does that make sense?
Yeah.
Okay. And I honestly didn't know if you were asking why. 8 and 9? Let's go through them. I'm on a roll. So they're saying the functions of time t. So right there, that tells you you're doing the like over dt stuff. As soon as they're functions of time. The sum of a and 3 times b is some constant. And then they're saying find the rate of change of b, but like we have to get to the derivative level because they're asking us for the rate of change. And you can see all the dA, dt, dB, dt stuff down here. So a is some function of time. Take the derivative of a, that would just be 1, right? But what do you multiply by? dA over dt. Plus, what's the derivative of 3 times b? 3, and then times dB dt. And then be careful over here. Yeah, this c is a constant. So what's the derivative of any constant? It's 0. And then you can, I think, see which one is which. That matches, right? If I subtract this part over to that other side, it'll be negative. So that's b. Try 9 then if you haven't. Try the 9 in. Remember, you have different ways to take the derivative, and you can choose which makes your life easiest. I think that one does. Like I can see some people doing quotient rule, and that's not wrong. I think it just makes it a little harder than it has to be. So I just brought that back on the bottom, that's m to the first, and I bring it up. Now it's the negative first. And L is a constant. I'm sorry. K is a constant. So I don't need to use product rule. It's just like 3x to the negative 1 or something. So I see this, and then they tell me K is a constant. And I'm like, okay, I could do quotient rule, but I don't really like quotient rule if I don't have to do it. I brought this up, and I just remember this is just a number. That's not a variable times a variable. I can just do regular power rule. The derivative of L is dL dt. Then bring down the negative 1, multiply by the K in front. Reduce the power by 1, then multiply by dm dt. And then that is this one, because they just put the m to the negative second, like on the bottom of the fraction. see. I want to show you like plugging numbers in. How does it look? And then tomorrow it'll be story problems with numbers. The first part of 4.5, they kind of give you the setup. So I'm gonna do number one, and then I'm gonna give you like I think 1 through 4 are similar. So I'll have you do like the 1 through 4, and then tomorrow we'll get into the rest with the story problems. The only way I know these are related rates is, well, you tell me, how do I know it's a related rates problem? Besides, like, it says solving related rates. That's a pretty big clue. Okay. The DT is your clue. So that, you know right away, if you see that, there's things changing as time passes. So X and Y are changing as time passes. So this is usually like a particle moving around. And I want to find dy dt. So I'm going to take the derivative of everything. So the derivative of y squared is 2y, but I took the derivative of a y, so I multiplied by dy dt. And then the derivative of 3x to the fourth is 12x to the third, but I took the derivative of an x. So I multiplied by dx dt. And then the derivative of 6x is 6. I multiplied by dx dt because I took the derivative of x. Some of these are a little bit annoying. They know, they give you enough to just be annoying because you have to do more work. So where I'm headed here is I don't know what y is. I also don't know what dy dt is. Dy dt is what I want to know, so I'm not supposed to know that. That's fine. But they were assholes and didn't tell me what y was. So how can I find y? So they gave me this equation up here, right? So if I plug x in, can't I find out what y is? So y squared would equal 3 times 1 to the fourth plus 6 times 1. So y squared equals 9. And I guess we're just supposed to assume it's the positive answer. There's really two answers there. I might do the notes for 4 or 5.
It does say plus minus.
You put like both.
Yeah.
But then 2 seconds later he says that negative doesn't matter.
Okay.
So he just uses the positive.
Like really what I'd want to see over here in the problem is like y is greater than 0, so I know which one to pick. But, okay, so y is 3. 12 is, or x is 1. What is dx dt? It's 2. What does it represent? The rate of change of x. It's like the velocity of x. So this particle's moving all over the place in circles and squiggles, but it's always going to be moving a certain amount in the x direction and a certain amount in the y direction. So the dx dt is the change this way, and the dy dt is the change this way. So it's still 2. And then you would just plug in and solve. Like there's just algebra. But more important to me at this moment, are there any questions on what I'm doing to get to that step? So that step is just like 6 dy dt equals 20, so 36. So then dy dt would equal 6. Questions on 1 there? So then, like I said, part of this is story problems and setting them all up, and part of it's just kind of plug and chug like the ones we just did. And I just want you to do those. So I would want you to do 1 through 4 for tomorrow. If you have questions on those, we'll go through those at the beginning, and then we'll start like doing the actual. So for tomorrow, you should have the notes for 4 or 5, and like the first 4 or 5. Fair enough? Good. Hopefully that helps.